Dear all, we are happy to welcome you to our webinar. My name is Olga Minzabrovska. I'm CEO and co-founder of HBM. And today we'll speak about testing. It's not a new topic at all, but still very often it's not implemented properly in organizations or in particular project as secondary practice. However, at the same time, nowadays, it's a growing demand to bring new features faster and faster to the market. And DevOps is a must-have, but how mature testing should adopt to the new DevOps cycle? Today, we'll try to address best practices within this, how to start, what to do, what to avoid. And recording of the webinar will be available afterwards for all of you. But first, let me say a few words about who we are. HBM is a boutique tech partner to the startups, SMBs, and enterprise, offering end-to-end IT services. Among our differentiators, I would list quality, speed, technical expertise, and value we bring to clients, plus flexibility and transparency. Since we are small enough, despite we're a relatively young company, our core team have been working together for more than 13 years, primarily serving enterprise, fintech, and Nordics market, and other large domains. Plus, in addition to recent years, we have heavily serving climate and energy startups in Europe. So we had collected big setup of delivery and talent management practices, best practices, which combined with our tech expertise allows to bring maximum value to clients and ensures customer satisfaction based on our surveys. We are originally a Ukrainian company based in Kiev, Ukraine, with legal headquarters in Hungary. Despite the war, we still focus on Ukrainian talents to retain this super technical expertise. However, majority of resources are located in Europe. This allows us to keep competitive advantage of technical expertise and scalability. As you can see, HBM is humans behind the machines, and it really reflects our culture. We really stand for human-to-human approach, communication with both our people and with clients, with everyone with whom we collaborate. We are inspired by meaningful projects that will make the world a better place. But enough about us. Let's dive into the topic. I'm passing the word to Kate Ovechenko, our head of technology, head of product management, true expert in testing and security, co-founder of the largest European conference in quality assurance, and just a great person. Welcome to stage, Kate.
Hi, everyone. Thank you, Olga. You presented me better than I usually present myself. So hello, everyone. Thank you for joining this webinar. My name is Kate Ovechenko. I'm head of technology department at HBM.ai. My main background is in software testing, so today I will talk about what I know the best about testing and about quality. Please feel free to write your questions along the webinar. You have a Q&A chat available. I will answer the questions after my talk, but you will be able to ask them afterwards as well. So let us start. The world is becoming faster. Businesses want to receive fast feedback from their users, and users want to release and to have new features faster in the product. Rules of the game has changed. Development processes need to become even more flexible to win this race. During this presentation, I would like to show you what place testing takes in this new DevOps environment and how the role of the test engineer changes in it. But first, let me start from the example. Netflix was one of the first companies who incorporated DevOps culture. Today, Netflix engineers deploy code hundreds times per day. but how they did it, actually. In 2012, operation of critical services at Netflix were laborious. Deployments felt like walking on wet sand, if you understand what I mean. Canary was devolving into verifying endurance rather than correct functionality. Researching issues felt like bouncing a ball between teams, hard to catch the root cause and even harder to stop this bouncing between different participants. All of these were signs that changes were needed in the Netflix operation. Releasing a new feature meant that developers need to coordinate with the operation team about different aspects of the further operation of a product, like metrics, alerts, capacity considerations. They handed off the code to the ops teams for further deployment and operation. Operate what you build is a concept that puts DevOps principles in action by having the team that develops the system also be responsible for operating and supporting that system. Netflix created centralized teams with the mission of developing common tooling and infrastructure to solve problems that every development team has. Today, deployments are routine and frequent. Canaries takes hours instead of days. And developers can quickly research issues and make changes rather than bouncing the responsibility across teams. So DevOps is all the rage. And prior to DevOps, agile methodologies generated the similar hype that forced businesses to spend millions of dollars or euros in a revamping organizational hierarchy and developing solutions in a new way. Agile was the answer to the drawbacks that waterfall methodology had. So in waterfall, you probably all know or remember, each stage of development has to be completed before we can move to the next stage. It made any changes difficult to implement and time-consuming. And delaying testing until the end of the development lifecycle meant that if we find a defect at the testing stage, then the release can be postponed even further. Agile was able to introduce testing earlier in the life cycle, eliminating this quality gate and ceremonies between passing code from development to testing. And now the same happens with DevOps. DevOps allows eliminate these ceremonies between software development and operations. As Netflix example shows us, DevOps means that whole team is equally responsible for a product. DevOps oriented from the attitude that developers care what happens with their code in production, and ops specialists care how code is being created. DevOps means that there are no walls, no gates, and no transition between development and operations. They are seamlessly integrated into one single value delivering IT chain. And for large organizations, implementing DevOps means an enterprise-wide transformation towards a radical new operating model. Introducing testing in agile and DevOps environments requires following some testing principles to make this process more effective. Write tests at the lowest possible level. It means that write more unit and integration tests. Favor tests with the fewest external dependencies and focus on running most tests as part of the build. Write tests that can run anywhere. So tests might use specialized integration points designed specifically to enable testing. You can either use publicly available endpoints to integrate or request a special test account to work with real third-party solutions. Design products for testability, meaning shifting the balance strongly in favor of unit testing over functional testing requires teams to make design and implementation choices that will support testability of the product, testability of the code. Treat test code as product code. So teams should treat test code the same way they treat product code, and apply the same level of care to the design and implementation of test scripts and test frameworks. And the last principle states that test ownership follows product ownership. Test code should reside next to the product code in a repository. For code to be tested at a component boundary, push accountability for testing to the person writing the component. Don't rely on others to test this component. And to implement these principles, teams can adopt a concept called shift-left testing. So shift-left testing is not something new. It's just the same old concept that just reappeared in this new DevOps environment. Shift-left, well, all of you know that finding defects earlier in the development lifecycle is much cheaper. Because the defect found at the concept phase can easily be fixed just with redesign of sub-mocks and prototypes, while defect found at testing phase or at release phase might require some redesign of the system, huge code refactoring, and as a result, massive scope of regression testing. That's why shift-left testing claims to move all testing activity to earlier stages. Shift-left testing strategy allows preventing defects and fix them earlier and cheaper. It allows releasing in time. The time that is now free up because we have less defects at the later stages can be used to develop more code and to develop more features and release them faster to production. Also, it allows to uncover hidden requirements or find inconsistencies in these requirements. So what can be shift-lefted? The first shift appears when testing is now more done manually, but is moving to the code level. Now we finally stop treating our software as a black box that does some magic transformation and returns us an output. We start analyzing the internal code structure and do white box testing. There are several practices and kinds of testing that support this shift. First, it's of course unit testing and integration testing that should be done by a developer and form the ground of your test pyramid. Test-driven development practice is also something that developers can implement and incorporate. Test-driven development is a software development process that relies on the repetition of a very short development cycle. First, the developer writes an initially failing automated test that defines a desired improvement or new function, and then produces the minimum amount of code to pass that test, and finally refactors the new code to some acceptable standards. The next shift happens when we move testing to design phase. This shift this testing happens before the code is even created. There are two practices, two concepts that can support testing at this phase. It's BDD, behavior-driven development, and ATDD, it's acceptance test-driven development. BDD is a software development approach that has evolved from test-driven development. It differs by being written in a shared language, which improves communication between tech and non-tech people and stakeholders. In both development approaches, tests are written ahead of the code, but in BDD, tests are more user-focused and based on the system's behavior. Usually, BDD uses given when then scenarios to write test cases for user stories. Like a practical example could be, given the user has not entered any data on the form, when they click the submit button, then proper validation message should be shown. So this is the example of a BDD scenario. ATDD, or acceptance test-driven development, is the practice of writing system-level acceptance tests for a customer-centric feature before the solution is created. So as in test-driven development, first acceptance criteria are formulated and automated, and then the code is created to fulfill these criteria. ATDD follows the same principles as TDD, but the focus is on automating acceptance tests. So usually these two practices are implemented together. Both BDD and ATDD are aimed on having conversations to help teams overcome misunderstandings in requirements and delivery issues. The next shift moves us to requirements phase and specification by example practice. This practice is a collaborative requirements discovery approach where examples and automatable tests are used for specifying requirements. thus creating executable specifications. A key aspect of specification by example is creating a single source of truth for our requirements. So when business analysts work on their own specs and tech specifications, software developers maintain their own code and documentation, and test engineers have their own test cases. Software delivery effectiveness is significantly reduced by the need of constantly synchronize and coordinate like the true requirements. With short iterative cycles, such coordination is often required on a weekly or bi-weekly basis. With specification by example, different roles participate in creating a single source of truth that captures everyone's understanding. Examples are used to provide clarity and precision so that the same information can be used both as a specification and business-oriented functional tests. In addition, information discovered during development or delivery, such as clarification of functional gaps, missing or incomplete requirements, or additional tests, is added to this single source of truth. So our requirements becomes our tests. And the last shift moves testing to the concept phase. At this stage, we test mostly overall idea of the product or feature. It's done with the help of A/B testing, some focus group researches, UX testing, and other techniques. Usually these techniques are used by product managers or product owners, but test engineers can help them to organize and coordinate this activity. So, although the testing is now blurred over the other phases in development lifecycle, there are still some activities that should and must happen at the testing stage. Now, test engineers don't have to verify every acceptance criteria or every edge scenario because these kinds of tests are run at development or design phases. Now, test engineers can focus more on exploratory testing of the application. They can focus more on end-to-end scenarios that run through several integration solutions. They can focus more on non-functional testing like penetration testing or something like this. While shifting left to automate testing is certainly important in DevOps, a shift right should happen as well. Essentially, this shift right is about moving some testing efforts to production. Testing in production doesn't necessarily mean execution of functional or performance tests against a live system. Testing in production allows detecting where errors occur and how users use the software in real life. It can be done by implementing monitoring tools in production that will inform the business about new tests scenarios that require further automation. A/B testing concept usually happens in production system. A/B testing compares two versions of product hosted in production. You split your production traffic between the two versions of the application and measure different metrics like conversion rate or something similar. A/B testing is done by real customers, providing a way of getting feedback from real users. Canary releases is another strategy, and it's used to reduce the risk of introducing a new software version in production. This is done by slowly rolling out the change to a small subset of users. And then if everything goes right, or if the system works okay, then this change is rolling out to a larger subset of the users. Fault tolerance testing is another practice that intentionally creates production failures and determines if the system under test is still able to operate under these failures. Failure will happen in any case, so why not to test possible failures in production yourself ahead of time? By failing quickly and inexpensively in a controlled environment, the developers and system engineers are guided towards creating a system that is more robust and can cope with different conditions. So now we see that testing is getting continuous, and it takes not just one step in the iteration or software development lifecycle, but it's implemented among all other stages. And the common delusion is to think that in DevOps approach, we need to automate 100% of test cases and test activities, and only by doing this, we will achieve the fast delivery and fast feedback. And this is not exactly right, as DevOps focuses on optimizing testing efforts. Optimization is usually achieved with test automation, but not always. To succeed, the teams need to build own test strategy and need to decide what shifts they want to do, what kinds of testing at what stage they want to implement, and build the correct ratio of different tests in their test pyramid. So they need to decide how many unit tests they will build, what will be the coverage of the code with unit tests, how many integration tests, what will be covered in a functional test, and what, for example, the manual test teams will test at the testing stage. So understanding how much testing can be automated and to what extent will help teams to form right strategies. Continuous development is the reality now, but most testing like acceptance, security, performance is still done in an iterative manner. There is greater emphasis on automated testing in DevOps as we want to create a culture where we can push code down the pipeline quickly and with confidence. Today, automating functional testing is quite routine. However, non-functional testing like security or performance is still done ad hoc and once some major piece of functionality is ready. The next step in continuous testing is to automate these kinds of testing and put them on CI to execute regularly and frequently. To succeed, automated tests must have zero human intervention and generate their own test data. All precondition, cleanups, post-testing tasks should be automated as well. We should also concentrate automation efforts on lower levels like unit integration, API testing, as it allows tests to be significantly less brittle and run faster. For higher level testing of the user interface, which may change much more often, manual exploratory testing is a better use of resources. A couple words about security, because there are more to the DevOps software lifecycle than testing and deployment. A critical missing piece is usually a security. And today, most advanced DevOps teams shift left security as well. So security is usually thought of at the end of the development lifecycle, at development stage or testing stage, or sometimes at release stage. But it can be incorporated into software development lifecycle from the very beginning. And it can use the same tools as testing uses, like continuous integration, continuous delivery, orchestration tools, to shift left some security checks and security practices to earlier stages. Yeah. So once the team has built their own testing strategy, it's now time to put them into the pipeline. You can plan at what step in the pipeline which kind of test will be executed. So what test will be triggered once the build is pushed into the master branch? What test will be triggered once the code or the build is pushed from dev environment to stage environment, and so on. Remember that you can automate code shift to the pipeline through the pipeline as well. You can set up quality gates at each step, and by this quality gate, the team can be sure that the code is moved further into the pipeline without critical errors. Example of the quality gates can be like some specific amount of tests has passed, or some specific code coverage is achieved, and so on. Just take into account that the stricter is the quality gate, there is more possibilities and that manual involvement will be needed because code will be stuck at some points. Like if you want to push code down into the pipeline only if all tests are green, there is a high chance that you will need to do it manually. 7 times of 10 and so on. So in this case, you need to find your own balance to understand how to configure it in a proper way. The roles of the DevOps teams, the roles in the DevOps team hasn't changed much, so we still have the same roles as we see in the Agile team. The biggest change that happened results from the increased responsibility. There is the need to pay closer attention to what happens to software in production. In a typical waterfall or even agile scenario, production is very much a black box for testers. Once code gets sent to production, another team looks at the error rate and checks calls from customers about issues. That team then logs those issues in the tickets and sends them to the test team. But this system creates a lone feedback loop and a lone feedback cycle that simply doesn't work in a fast-paced DevOps environment. So the requirements to each role has increased. The test engineer in particular are now act as a consultant to the developers, build and run automated tests, doing usability testing and exploratory testing. Two separate roles are present in the team with different focus. Test automation engineers focus more on automating functional and non-functional tests, while test managers or test engineers focus more on exploratory testing and other manual testing activities. DevOps is also all about the tool set. During the recent years, there appeared a lot of tools that can help to automate different stages of this DevOps cycle. I will not stop on the tools exactly because there are plenty amount of it and they all depend on your environment and your context. But just remember that you can automate almost everything to some extent, and there is usually a tool for it. If you got excited about what I told, how we can shift left testing and shift left security and do very, very fast releases to production, you probably, the next question you get is where to start from. Yeah, how can I achieve this fast feedback loops? Unfortunately, there is no like implement DevOps for rookies, or implement DevOps in any team guide, because every case has its peculiar requirements and specifics. You cannot standardize what has worked elsewhere, because it has worked with different tools, with different mindset, different organization, and different people. But you can definitely learn from other people's experience. However, I can give some just general advices, what you can look at to start thinking more about continuous testing and DevOps. So first, define test strategy and proper test ratio. It means define what kinds of testing you will implement, at what stages they will be implemented, what will be the percent of tests at each level. Start with introducing unit testing if you don't have it, or if you have it, just verify the coverage and maybe you need to increase it, and then move up to through the testing pyramid to integration and functional tests. Check what kinds of defects sneak through your tests and do require tuning. I mean, if you check your Jira or other defect tracking tool and you see a lot of defects like service isn't available or some internal server errors happen, maybe you need just to introduce more integration tests, and these defects will be found early in the life cycle before the build is even deployed to test environment. Introduce dedicated testers to do functional and exploratory tests and automate these testing where possible. There is for some reason, there exists a rule that developers can't test their own code. Of course, they can do some unit testing, but they can't achieve the independence of mindset by testing their own piece of work. That's why we need to introduce a dedicated testers who will do testing full time and with required focus and responsibility. Define proper quality gates in the automated pipeline. So define what will be the rules for your code to move through the pipeline at the later stages. What will be your requirements to this code? Either you want all the tests to be green, or you want some test coverage ratio, or whatever. So you need to define these quality gates, and the toolset will allow you to configure it properly. And of course, track metrics and adjust on the go. Talking about metrics, there are some ideas on how you can measure the success of your DevOps process. Most articles about DevOps, they define 4 main metrics to indicate the success of your DevOps environment or DevOps operation. Lead time for pipeline execution. It is the time it takes for a pipeline to push the code from beginning to the end. It also represents the time it takes for your developers to receive fast feedback on the quality of the code they commit, so they can identify and remediate any defects. Long lead time are almost guaranteed if developers work on large changes that exist on separate branches and rely on manual testing for quality control. Mean time to recovery is defined as the average time between failures to their next success. After you get a failed signal, like failed build or failed test, the ability to address this issue quickly is invaluable. Because mean time to recovery improves with more comprehensive test coverage, this metric can be a proxy for how well tested your application is. Solid test coverage reduces the fear of for developers to introduce a broken code to production, allowing you to challenge your engineering teams to be creative and nimble with the solution they develop. Deployment frequency is defined as the average number of pipeline runs per day. The number of pipeline runs indicates how many discrete units of work move through your application development pipeline. Are you pushing many small changes or fewer large changes? The right size will depend on your team, but the goal is to have units of work small enough so you can debug quickly and easily, but big enough to introduce some significant and meaningful change. And the last metric is, of course, the success rate. Success rate is defined as the number of passing runs divided by the total number of runs over a period of time. High-performing teams have success rates in around 85 to 100%. The same practices that enable shorter lead time, like test automation and working in small batches, correlate with an increase in success rate. All these practices makes defects much easier to identify and remediate. So, of course, this list of practices isn't limited with what I named. So you can define your own practices that will represent the success or the effectiveness of your own process. And a couple words about value of introducing DevOps into the organization. Practicing DevOps as an organizational culture helps you to get latest practical answers to key business questions. Like how do we improve the quality of product delivery to our customers? How we change product? Can we change product more swiftly and satisfy our customers in a better way? How can we recover faster from the failure? How can we get a quicker feedback from our customers? All these directly impact sales, revenue growth, profitability, product line, business viability, and customer satisfaction. And of course, as a result, all this relates to the success of your business. So, if you will learn something from this presentation, I would like you to learn that DevOps is a culture. So DevOps practices provide the great business value to organization by enabling them to transform swiftly and safely. But DevOps isn't a specific role. It isn't a one person in your team. It's a culture and method for continuous improvement, collaboration, and transparency to drive success and business value. Success not only in creating a reliable software and engineering practices, but also in driving revenue and operation proficiency through the entire organization. Yeah, that's it. Some sneak peek to DevOps and continuous testing. Thank you for your attention. You can write your questions in the Q&A section, and I will try to address them now.
Thank you, Kate. It sounds, not so complicated, but from practice, we know that in fact it is. Yeah. Can you open next slide? While we are waiting for questions, I will just conclude what actually HPM delivers, especially in testing area. Yeah, thanks. So as you can see, actually our main service offering is technology partnership, which we offer to companies to deliver end-to-end IT services, from ideation to implementation, cloud management, and maintenance. For startups, in addition to a previous item, we can heavily participate in shaping solution, shaping product strategy, selecting right features, building MVP fast with high quality, and then do following go-to-market activities. Of course, we can do fragmented, very focused IT consulting to focus on specific need, or we can do also product marketing, where team can jump on any stage, like at the very beginning, which is recommended, of course, to focus on right target audience, focus on competitive advantage features, building right product and product marketing strategy, or later to do ongoing go-to-market activities and clients acquisition. And in any model, we can either take full responsibility for solution, for service, or embed into client larger setup. Next, please. Yeah, thanks. So it helps to address very typical client challenges, like helping with either expertise or capacity or cost or quality, or all together, actually. And typical projects are kind of listed to the right. Usually, especially last years, we built solutions from scratch where we take full responsibility end to end, or we built integration platforms or integrate ready solutions. Of course, migration to modern technologies, moving to cloud and further operation there, and introducing testing or test automation, and even building test practice for the whole organization sometimes. And actually more details on next slide. Testing have been our key expertise areas for years and offering, and we had plenty of projects focused on different things, actually. But in general, we can represent it like on the slide. Either we implement test practice or help client to do this, or advise, to do ongoing test management, test design, testing, assuring quality of release. Or it can be in addition or standalone, just test automation, where we build modern, effective test automation solution to streamline releases. Test advisory, very often we are asked to just to do assessment, to investigate case, and just recommend client how to address their quality issues. Or we had cases when we helped to establish the whole test center for client. It included organizational setup and staffing and building competence, helping to actually develop and do further test activities on client side fully. And next one, I think last one. Of course, if any of you have questions and need professional advisory, free of charge, we are ready to have your individual workshop, diving into your problem, your pains, plans, your setup, processes, solution, how it works today, what are the issues. We can suggest actually a solution, not big bang, but having holistic picture in mind. We'll advise how to move forward, improving step by step. with low-hanging fruits and to receive value as soon as possible. Just contact us from the website and we'll contact you very soon. I think that's it actually for today. Let's check questions. Okay, I don't see any. Of course, we will share recording of the webinar, so you'll be able to send questions if any will come up, or ask for related questions or deeper questions. We'll be happy to address. Thank you all for attending, participating. Kate, thank you so much. Wish you all a good day and good week. All the best.